recording. There we go. All right. Yeah, so as Kaushik was saying, we called this meeting, or people asked for this meeting last time to go over the proof of concept. And I think the hope was that people would have taken a look at that before we went here. So I don't have the demo set up and ready to go again. Because we had asked people to look at the video, so hopefully we did. I'm happy to talk through the presentation some, answer questions. The thinking around some of these things has evolved a bit since that proof of concept, but I think it's nothing major, just more refinement to the concepts. Yeah, I mean, how do we want to proceed? Anybody have questions, or I can bring up the presentation. We can talk. I can talk it through again and sort of refresh everybody. Okay. Why don't I do that then? Or I can sort of refresh on what. Let's see. Oh, I need to go to the other agenda document.
So John, maybe if I may, it's Wim here. It might be good to basically discuss the big concepts behind the demo. I think what might be the most give the big bang for the buck, right? So that we say that's the philosophy, or these are the things that we are trying to achieve, or that's the philosophy behind the demo.
Okay.
Does it make sense?
Yeah. So okay, that's fine. Let's let me. Actually, I'll bring it up as the deck instead of the PDF. I think I have that. Yeah, let me. So the basic idea, there's actually, I tended to focus on one particular thing there, but it probably was too. I would probably needed to zoom out a little bit. So I'll try to zoom out a little bit in this discussion. So if you look at what the goals of the PoC were, one is to demonstrate kind of the life cycle of how a workload package would be configured and processed through the Nefio platform, and the reason, or I will say, I guess, that it doesn't have to be a workload package. It could be an infrastructure package. It's just pretty much any set of configuration that's represented in Kubernetes format. And we have a follow-up potentially for demonstrating an infrastructure one too, that Sandeep, I think, is working on from Arna. So the idea was, we have two, so I'm going to switch back to where I can see people. Okay, we have two kind of, and I think, unfortunately, I haven't gotten a chance to watch Tal's presentation, but from what Stephen's summary was, I think this is very much in line with the way Tal's thinking about this too. So we have two sort of places in which we can put sophisticated logic. So if you look at this, I can't click on that. I have to go back here. If you look at this, what I'm calling the package lifecycle, remember that the general idea is you start with a package that's maybe in a vendor's catalog. I can make this bigger. like in a vendor's catalog, and you move that. So that's represents some network function with sort of the vendor's expectations of the basic configuration of that, best practices, but there's going to be there's nothing specific to your environment in there. So what you can do is start with that. You clone it into your own private catalog. And from there, the design team, the platform team, whatever you may call it in your organization, can take it and customize it, or adapt it is the words I'm trying to use, adapt it to the particular organization. So that could be put certain organizational policies in there. It could be set it up to work with the organization-wide monitoring platform that you have. Pieces that are not specific to an individual deployment, but more to the organization itself. And that then gets submitted and proposed and approved, put into a private catalog that's just for that organization. So then deployers can pull from that, and they've already got part of their work done. They've got some of the work done. They take it and do the same process where they edit it and they add in, say, configuration specific to a given instantiation of that package or function. And the interesting thing here that we're trying to introduce is the idea of a controller that can assist in that configuration. And in the demonstration, so this is the public catalog. Can you see my mouse? Actually, I think you probably can. Starting in the public catalog, you move into the private catalog, draft, move to the private catalog, published. And here, actually, the demo actually takes place right here with a controller that takes that and fans it out across multiple deployment draft branches. This drawing wasn't specifically made for this demo. This drawing was more general purpose. And the idea would be then you can have subsequent controllers in humans that actually modify that initial draft created by your fan out controller and eventually decide this is ready to publish or to deploy. It goes into a deployment repository. And this line here where it says pull, so this is an important line. This is the line between things that happen sort of in storage and have zero initial, have zero chance of causing a failure. Or maybe it's even this line right here before it gets published and approved. But basically, everything to the upper left here, anything we screw up in there during this process will not cause operational failures because it's not going into operations. It's not going into runtime. It's simply sitting as configuration in a storage repository somewhere. Once it gets below this line, so we have what we call apply time. Apply time is when we take the configuration, and we copy it out of storage and we apply it to the API server. That's apply time. And then runtime is after it's in, or there's admission time, which is sort of within the Kubernetes API server, there's an ability to affect the configuration. And then finally, it's stored in the configuration in the API server. And then there's runtime. So operators, as we talk about them in the Kubernetes sense, happen at runtime. Everything they do is at runtime. And therefore, when an operator has a bug or makes a mistake, the operator can cause failures in operations, like the actual service can fail. Everything that happens above that line can't. So my contention, and I think that we're generally in agreement about this, is that as much as possible, we move our manipulation of the configuration into the pre-apply phase. All of those phases, which include the vendor creating the initial configuration, the organization adapting it, maybe an application team adapting it, and a deployer finally doing the final configuration and deploying it. And we can do validations at that layer. We can do as much as possible at that layer. before we get to a scenario in which we can cause operational failures. So that's kind of the big overview. I'm going to pause there if there's any questions before I continue on. Okay, I don't see any hands. So then what this particular demo tries to do, like I said, it inserts itself right here. So rather than this going from a private catalog main branch to a deployment repo, single deployment repo draft branch by a human saying, clone this package here to here, we've inserted a controller that reads a separate resource out of, we have that controller running in a management cluster. We put a Kubernetes resource in that management cluster that says, deploy a package from here across these several repos. And as you do that, note that there are differences between each of those clusters that are served by those repos. And so customize the package automatically based upon the differences in those clusters. So if we look at the next slide, this is kind of the setup in the demo. We have this management cluster. It's running our PoC code. We have workload clusters down here, and those have config sync, which is the thing that does apply. It takes from the repository and does the apply. We have all kind of the basic setup done. Now in the Nefio sort of full incarnation, basically this piece is installation of Nefio, and all of these other pieces can be done by Nefio. So the idea is, and this is the other demonstration extension of this that's being worked on, and I don't know if we have, let's see who's here. I don't think we have, shoot, okay. Yeah, so Sandeep Sharma, was somebody saying something?
It's Eric. So a question maybe for the different cluster, how did you configure them previously to run this demo? Is it a specific configuration for that, or?
Yeah, so what I did is, if you look at this, which says setup guide there in the bottom left, that actually goes through how I set all of this up. And I think it covers everything.
Okay.
Basically, the clusters themselves, I just instantiated new clusters. I instantiated repositories within GitHub, and then I installed config sync on those clusters. That's all I did. They're otherwise empty. They just have config sync running on them. But the guide will take you through setting up this whole environment. So after we did the demo a few weeks ago, Sandeep Sharma, who I don't think is on the call today, he reached out, and he's going to extend the proof of concept to show how we can actually use it to instantiate these clusters as well. There is one thing that I don't yet know how we're going to do, and that's that thing I said, install config sync. In the sort of Google world, we have a way to do that. I don't know of a way to do it in open source right now, so that's something where we need to figure out as a community. And the reason is this: you see that these clusters, the way they get their workloads is by reading this repository. So if I want to automate deploying a workload, I just stick it in this repository. That works for every single workload except config sync, which has to be bootstrapped such that it's there to do the apply. So in the setup guide, I manually do it, right? I just manually install and configure config sync to point to this repository. What ideally we want, if we're using this infrastructure to actually deploy to actually create the cluster by deploying a bundle of KRM config to a cloud management cluster, then we want a way to declaratively say, not only create the cluster, but install this particular package. I know how to do that with Google as the cloud provider. I don't know how to do that with other cloud providers. I don't know how to do that if, say, you're using some internal on-prem. There may be solutions to do that. I don't know what they are. So this is an area we need to figure out. Okay.
Well, if we have a controller that initiates the cluster deployment, then that controller could take care of deploying any other additional packages like conferencing, isn't it?
It could, and that's effectively what we do in our, in the Google solution. It's just that you end up with complexity around connectivity. So like, because my controller has connectivity to the cloud provider API service in order to instantiate a cluster, does not mean it has connectivity to the API endpoint of that cluster it just created. And so that's where it gets hard. When everything's public IPs, it's not hard. When everything's internal, including that service that creates the cluster, it may also not be too hard. Where it gets hard is when that controller that instantiates the cluster is not running in the same VPC that the cluster's API server endpoint is running in, and I don't. And in Google we have a service. We have a thing that, we have a way to bootstrap that whole process, and other cloud providers might as well, but I'm not familiar with them. Okay, so all right, so let's see the setup. I'll go back to that tab. Okay, so this is the general setup, and then in this document, if folks got a chance to review it, I define a few, and I can try to run the demo. I just literally haven't, because I should have thought about that. People maybe didn't have a chance to watch the video, but I can see if it's up and running. But in this document, what I'm trying to do is demonstrate this overall process with a simple workload. So the specifics of the workload aren't that important as much as that that we're exercising the machinery. But there were a few points that I'm trying to make in there. In this process, I want my controller here, that's a Nefio controller. I don't want it to have specific knowledge about the packages that it's deploying. Now, eventually we will get to where we have a Nefio controller that understands, say, a specific use case around 5G topology, for example. And it will understand certain aspects of those network functions and the relationships between them. But it shouldn't, say, for example, understand vendor-specific aspects of those. So there's a sort of way in which we want to surface the pieces of information that we care about and are common and are subject to our automation, and we want to obscure anything else so that those controllers are built on top of the sort of pure interface that it understands, and both the packages and the controllers sort of don't need to understand each other. They just need to understand that common interface. So this is one of the things I was trying to elicit with this demonstration. The demonstration, therefore, that's what I call in the demonstration. I do that with something called a cluster scale profile. In a real Nepio environment, that actually might be something very different, like sort of semantic information about. Well, this is a little different. Actually, I don't. Sorry, I'm going. I may be mixing two things in a way that they're fundamentally the same, but it's going to cause confusion. So in the case, there's multiple cases in which we want to follow this pattern. And in the particular case I demonstrate, I want to follow this pattern with respect to the package not having to know about sort of the or the controller rather not having to know about the details of how to scale a particular application or package, but the package itself being able to sort of contain that knowledge of here's how I scale, and there being a common language by which the controller can sort of indicate, hey, package, you're being installed in this particular cluster, which has this particular context around its scale, this particular profile of scale. And so in this environment here, what happens is inside of the management cluster, I have a cluster custom resource defined. Associated with each of those cluster custom resources, I have a cluster scale profile resource defined. And that cluster scale profile contains sort of very basic information. Let me see if I can pull it up. Let's see, let me split this window. Of course. You know what? Okay. So what that look like? So it's easiest to look at the examples. So the cluster here, is that yeah, it looks like it's pretty legible. So the cluster basically just associates a scale profile name with it. So in this case, what I'm saying is I have and some labels. So I have a regional cluster in the US Central 1 region, and that's a large auto-scaling site. I'll show you what that means in a minute. And then this is the repository used to put workloads into that cluster. So in my diagram, this is the repository that's one-to-one associated with that cluster. Similarly, I have Nepio Edge 01, Nepio Edge 02, and those are site type aggregation and region US Central 1. And each of these, this one's a small fixed site, and this one's a medium fixed site. So what do those scale profiles mean? Again, this is not a realistic
So
values, resources.
Sorry, just to check my understanding. So that would realistically mean that the state of these cluster custom resource instances would form a kind of a cluster registry in the management cluster that contains all the properties of the clusters that we care about in Nephew. Basically,
Yes, something like that. Right now, how do you populate that cluster registry? So that's exactly right. It'll contain a cluster registry, and then we can have separate CRDs that describe different types of characteristics of each of those clusters. So for example, in the case of GCP, any cluster has to be associated with a project. There's a project ID associated with it. There's a region. There's an availability zone if it's a zonal cluster. If it's an edge cluster, of course, it's a site, so it's associated with some individual geography. So like there will be different sets of information that we want to, or demographic information, I would say, about a cluster that we care about. And what I would hope is that out of this group, we would come to understand what are the important sort of sets of attributes and how are they organized. So in sort of what I'm hoping Vance will talk about in his presentation next time, the information modeling, like in that sort of information modeling thing, what are those significant things, and which ones of them sort of represent meaningful, which of those will introduce meaningful differences in configuration within our workloads. So I picked some random things like scale that I felt demonstrated that concept, but it will be this group that knows these workloads and knows their networks that would maybe be able to give us information about what actual real values are useful here. So in my demonstration, I just picked this idea of we can characterize the scalability of an individual cluster based upon whether it's auto-scaling or not. If it's auto-scaling, or the maximum number of nodes, if it's not auto-scaling, the exact number of nodes. And then this concept of site density, meaning it's urban, it's rural, it's like what's the expected sort of level of activity that might be coming through that site. Now, those are probably not realistic, but it was something to demonstrate. So, is there a comment?
Oh, John, just maybe it's just one thing to clarify. So I think the cluster CR itself could be used to actually deploy the cluster eventually. Or is that understanding correct?
Yeah. So that was so I would say yes and no. So when we look at, I would almost invert it, and this is
Okay.
We've talked about this concept before. So Nephew itself doesn't need to know how to deploy clusters. Nephew needs to know how to process a bundle of configuration resources that represent a cluster, and tell a cloud management service to deploy that cluster. So this is where we start to try and get this separation of concerns. I don't want to try to replicate the concept of a cluster with all of the variability that goes into that. And this exact pattern goes back to network functions. We don't want Nephew to have to understand every detail of every vendor's network functions, right? That would be impossible. Similarly, we don't want Nephew to have to try to understand every detail of every cloud provider's clusters. We also don't want Nephew to pick a set of attributes and say, these are the only ones that can be changed through Nephew, and we create a lowest common denominator orchestration service. So how do we avoid that? I say we sort of identify, this is a subtle difference between the lowest common denominator and what I'm going to talk about, but I think it's a material difference. we identify the set of things that Nefio wants to actually automate or operate on, and we tease those apart, and we create a Nefio specific CRD that contains that information, and then that information basically gets included in the package that represents a cluster. So if we think about that a package, which is just a collection of Kubernetes resources, if we've moved our cluster creation operations into Kubernetes resources, then we can create a package that a human can go in and customize to their heart's content with all the resources and all the details for a very, this is what my regional clusters that are going to run core network functions looks like. I put that into a package, and one of the resources in that package is this Nefio stub that we can use to feed the process within Nefio that can this effectively is the entry in the Nefio cluster registry. So then we can drive this process of installing workloads. So that's kind of the concept, is that Nefio only needs to know about that. The rest is left into the hands of the sort of cluster operators. And there could be a controller, and I see your hand, Tal. There could be a controller within Nefio that sort of uses, that takes those cluster packages and does the same thing I'm doing with the workload packages, driven by, say, some sort of site resource. So we know we've got physical sites out there with this many nodes, and we can pick a package. In our case of this demonstration, we're picking the core DNS package, but that package could be a regional 5G core cluster package. And we are then looking at our cloud regions in a particular geography, say, and we're instantiating that in each of those. Yeah, Tal.
Yeah, so a word you're not using, and I was thinking of, is policies. I understand these cluster scale profile resources to be policies, right? Rather than this is the custom resource that defines and creates the cluster. Rather, this is a policy required by a network function, so it'd be packaged with it, and it would have to be applied, right, for the cluster that exists, or during installation, or during assignment and allocation of the cluster, right? Is that how you understand it?
Yeah, we could use the word policy. I'm not quite sure I'm following the distinction, but when we instantiate, I don't know, Wim, did you have a comment on Tal's comment, or is it a different topic? Because I want to finish this.
No, just do this. I had a comment on what you were saying before. Okay. But just finish this first. Yeah. So yeah, it's a different comment, a different question.
So when I think policy, I tend to think about constraints that are applied by, say, a central organization on individual deployments. I mean, policy is a very general word. So when I hear policy, that's what I think. And I'm not sure, is that what you're talking about? Or are you talking about a different meaning of the word policy?
I know the word is very overloaded, right? We have policy frameworks used at OSS, VSS levels. But in this case, I know I do mean something close, I think, to where you're thinking is to. Maybe I'll try to explain, right? These are constraints in a way. What you're defining here, especially, is a scaling constraint, right? You're saying that I want the cluster on which I will be installed to follow these scaling behaviors. So this is a policy for scaling. We could call it a scaling policy.
Yeah, I mean,
the other word I can think about, Tal, what you're saying is it like a deployment requirement? for the network function?
Right. At the end of the day, this is a requirement, but I think we're realizing that we need diverse kinds of requirements, right? Some requirements would be, to an extent, everything you specify in Kubernetes is a requirement, right? Because it's a pod is a requirement. You're saying, I want the container runtime to create this pod for me, and I can attach an affinity to it. The affinity would be a policy, right? Because the affinity would say, I want this to behave, and these are the constraints, right, John, as you said, the constraint. In this case, too, I would say that I need a cluster with this behavior. I'm not telling you how to install the cluster. Maybe the cluster is already installed, right? Maybe it's already a pool. Maybe it's there on the site, and I just need to use it and allocate it for me. So fulfilling a requirement does not have to mean provisioning something new, right? It means I need this, get it for me.
Yeah, and I think that's gonna, and I think that that idea of we don't necessarily need a provision is super important, because eventually we're going to want to do things like, I think people have talked about slicing, right? A slice isn't going to necessarily instantiate, it may instantiate some new functions, but it may simply reconfigure functions that are already there. So you may need to land changes and schedule changes against a topology of functions. So that's not provisioning. So yes, fulfilling requirements, I definitely like to think about it that way as well. I think we have a few hands, but Wim, I think your hand went down. I know, Ravi, you raised your hand, but Wim had a hand before we even got it.
Okay, yeah, sorry, I still wanted to raise my hand. Sorry, I don't know. Yeah.
Well, I guess first is Ravi, is it in response to this specific conversation? Because we should probably.
Yeah, okay.
Yeah, thanks, John. So, I mean, because we are talking about cluster management, just wanted to understand, eventually, I hope there will be, things like use cases and requirements explicitly spelled out. But do you think, right, I mean, from your thinking, do you see things like inventory management, software management, and, all the things about managing the the physical assets, FMPM kind of alarms and all those metrics being handled by Nephew as well? Or would that be something that you say should be handled local to the cluster or somewhere in the regional edge or something like that?
I'm not sure I 100% understand, but I'll say what I think, and I don't know if Kaushik or somebody might have a comment here. Definitely, so in the My Mental model, which granted comes from sort of what we do internally in Google and that, yeah, we would represent the physical assets out there in this cluster as well, and there does come a question about reservation and allocation of those physical resources and where that happens. I know Stephen is looking at some of this as well in his thing he's working on, but some of those, if we need to reason about those allocations in our sort of cluster placement decisions, which we likely do, then they probably have to bubble up to the management layer. So there will always be, for any given, there's two ways to do it, right? You can, and I think we'll have to figure out as a community based on our requirements, like you can discover the available resources and have them sort of reported back to the central cluster, which can then reason about them, or you can sort of a priori allocate them within the central cluster. So it's not clear to me what people want right now. I don't know if anybody else has a comment on that.
Yeah, because I was asking this question because when you provision a cluster, you should know exactly what is available from a physical resource perspective, and if the workload that you're going to run on it would be kind of would meet those. I mean, the cluster would at the end of the day would meet that specific requirement or not. So unless you have that inventory information, you may not be that you may not be able to take the decision.
Yes, and in that sense, yes, we absolutely will need it. We'll need it, and we'll need to model it, but we'll need to figure out how to model it in a way that, doesn't tie us to specific cloud providers, it's going to be a little challenging. But what I'm imagining there is for example, I can only talk in sort of like what I know, which is if you go to the Google Cloud API, you can say list all of the sites in which you've got hardware installed, or you can list all of your regions where you could potentially create a cluster. We can create a controller that synchronizes that into a Nefio set of resources. Then we can also create a controller that synchronizes the similar information from AWS or from Azure or from some on-prem inventory system and puts it into the Nefio management cluster in that Nefio representation. So this is a sort of a controller that operates on top of those cloud APIs that's effectively one way at that point, and just says, here's the available physical resources out there. When we go to instantiate a cluster, we will need a way to make sure that the cluster we're creating can be met by the requirements at that physical site. And this is likely where the package that represents that particular bundle of configuration that is specific to that cloud provider's environment will need to be able to understand that resource, that common Nefio resource that describes capacity demands, capacity requirements. I hope I'm not being too abstract, but
No, I think these are relevant discussion because you need to understand what information is gathered by Nefio, right, for provisioning these clusters. I mean, all things related to information modeling becomes very important, and that has to work across cloud providers.
Yeah. See, it's almost like, I think what you're saying, Ravi, is also earlier, it reminds me of the BNFD template, where you actually are giving the deployment requirements, right? It is the equivalent of that published by the network function vendor that needs to be translated to what you want to create, what you want to translate it into this cluster scale profile and cluster.
Yeah.
That was a parallel I was trying to draw, if that makes sense for people who understand BNFD.
it looks like Kaushik and then Wim. Yeah.
Yeah, I would say that I think we should, this is a fairly involved topic also because right now we have been kind of assuming single tenancy for the edge clusters. But if we do get to multi-tenant edge clusters, it becomes even more intricate. And there are some customers that, at least for some of the Google Edge Cloud GDC, we are looking at multi-tenancy as a goalpost. And we haven't like internally figured out like how does resource sharding work, right? Is it pay per use based on vCPUs and other resources, or is there a different way to slice and dice? Because that also ties into the management cluster having a hook into what the resource a priori allocation per tenant looks like, and then for the tenant, then you need to do the second order of allocation on demand.
Yeah, so I think that all of these are information modeling questions that we need to answer, and I think that we probably need to have these meetings. Like we probably do need to have these meetings every week. I think that next week is Monday's Labor Day in the U.S., which means those of us in the U.S. won't be at work. But maybe we should reschedule. Kaushik and I were talking about this before the meeting. Reschedule the Monday meeting to another day next week. But William, why don't we hear from you? You've been waiting very patiently.
No, I heard sometimes a bit conflicting information, and that's why I wanted to clarify a little bit, because sometimes we say cluster configuration we don't want to do, and sometimes we say we would do, but I think, and then we say we only want discovery, or so because any
Yeah.
scenario, I do agree it's a complex topic, John. Don't get me wrong, right? But even if you want to discovery, you have to deal with the vendor underneath, right?
Yes.
So somehow we'll have to deal with somehow multi-vendorish thingies into Nephew. What I understand that you said before when I was clarifying, at least we need a CR that represents the constraints or the resources that we rely upon, right? So I don't think there's a dispute there. And
Yeah.
of course, option number one can be we configure them. Someone configures them manually, and the consistency is out of scope of Nephew as a first release or something like that. That could be the way forward, right? But sometimes, so we have to at some point say where we want to go and where we don't want to go, because otherwise we continue to boil the ocean left, right, or center. That was that was my point. And I think your first stance potentially is let's create it manually. Let's define the constraints that we rely upon in the first release, and let's start there. And if we want to make it more discoverable, inventory creation, let's discuss whether we can do it in phase 2 or 3 or 4. And I'm just making maybe statements that are not correct, but I think that's where I'm hearing the discussion going a little bit to where should we, to what point should we go somewhere? And I think we have to probably decide upon that at some point.
So no, your point's well taken, and it's a good point. So what I'm trying to I'm trying to decouple the fact that we have a cluster registry from how that cluster registry gets populated. So that cluster registry may be populated. If we're instantiating the cluster, we can, with the same bundle of configuration that we submit to create the cluster. Now that's a bunch of cloud provider specific bundle of resources that Nephew doesn't have intimate knowledge of, but it knows that represents a cluster maybe, because included in that bundle of configuration, which might have 20 different resources, is one of these resources that's on the screen. And similarly, that's ones that we provision. Now there may be others that get provisioned out of band. Those we may have a piece of code, cloud provider specific code, that sits and runs in our Nephew cluster, that goes to that cloud provider API and reads all of those clusters and creates one of these for each of those clusters. We may have a separate one running for a different cloud provider in the same Nephew cluster that populates the cluster registry with those. So clearly a layer would have to be, which cloud provider it's focused, which cloud provider it's in. So decoupling how that registry gets populated from the fact that there is a registry, so the consumer of the registry doesn't actually have to care how it got populated. That's my main point. That's why it sounded a little conflicting. It wasn't so much that we won't provision, it's that we want to decouple those two things so that we can do it in all these flexible ways, and we can layer in and add more and actually do them all simultaneously if we want. Does that clarify a little bit?
Oh, that's right. Yeah. And I think we have to then define the scope, right? Is where, because I do agree with you is you need this information to do the next step, right? So what you're saying is, okay, this information somehow is populated from something. How at this stage you don't care whether it's automatic or manual. You basically don't care. Yeah.
Exactly. And in my demo, that's why I did it. In my demo, I did it manually. Right? I just cube control apply. Right. And but that's as others have noted, and as actually Sandeep is talking about extending, like we could actually, I mean, even though the PoC, like if you look at the code, the PoC this is nowhere near production quote code. This is very much PoC code. Even so, it's general enough we could actually extend the PoC so that we use the same machinery, the same controller to deploy a set of clusters, and then with a separate resource, we have the controller actually deploy a workload across those clusters. There's some gotchas there, like I talked about in the beginning, around bootstrapping. and instantiation of repositories needs to be able to be done declaratively through KRM, which I know we can do at Google. I think you could do at AWS. Sandeep is looking at doing the demo for the extension of this with AWS, so that could be interesting. We only have 5 minutes left, and we kind of, I didn't obviously do the demo because I didn't really, I was hoping people would watch the video. I don't like watching videos myself, so I understand if people didn't. Maybe we should take this last 5 minutes, and I don't know if we can do a poll on what day is best for people next week. Like, we just sort of picked Wednesday 8 a.m. this week for this ad hoc meeting, but what do you think? I think there's a way to do a poll in here, but I've never used it.
Are you talking about moving the standard architecture meeting?
Just a one-off reschedule because of Labor Day next week.
Oh,
Yeah,
right.
just for next week.
Sorry, I forgot about that. I think it would be very hard to do it a poll here. Maybe we can send an email with a poll or something like that.
Yeah, that makes more sense. That's a good point. Yeah. All right. Well, yeah, I don't want to necessarily. Well, any other questions? Or I didn't finish even talking through like all of this, but given the time, do we want to continue on? I guess I'll show the resource. Let me display this tab.
I do have a little question.
Yeah.
So, John, did you have a chance to watch the bifurcated orchestration presentation?
I haven't yet, but Stephen gave me a quick. It sounded like it was very in line, but I planned to watch it today. I just didn't have time yesterday. Like,
I don't know if everybody would think it's that important, but it's important in my mind. And it's important, I think, to what you're doing here as well, because my kind of overarching argument there is that a lot of what we do in NetView would be running in the management cluster. And exactly, I see things like basically everything you showed today and you talked about would be operators running in the management cluster, right? Because the workload clusters don't exist yet. These define the workload cluster.
Absolutely, and I 100% agree. Like, that is my. So in the beginning, I shared this diagram. 1 second. This diagram, and what I talked about, I'm not sure if you were here, is there's a line right about here between everything above this line is happening in the management cluster and can't cause operational failures because it's not going into operations yet. It's just in storage. And once we hit this line, once we publish this and it goes down and gets applied, now we can cause operational failure. So if you think about where do we want to do most of our heavy lifting, I suggest, and it sounds like you are in the same boat, that we push as much of it up here so that we can put as many validations, gates, and reviews as possible before we go to operations, rather than down here. A typical operator workflow of like, you create a CR and the operator takes over and does everything on the edge cluster is all done at runtime. And if there's a bug in there, there's lots of problems with that. Like, if there's a bug in there, it breaks operations. If there's a bug in there, you can't actually do anything about it because you have no control over what's there. It's like the vendor's operator that has to be
right
fixed.
I'll just add a point that day two is important as well, right? It's not just that moment when you pass the torch, the baton. The baton is constantly passed, right? If you edit that profile that we talked about, we would expect something to happen, right?
Yes.
In a truly declarative environment, you could change the scaling policy or a scaling profile, right? And what that would mean, of course, could have huge implications, right? Would the cluster need to be reinstalled and everything done again to tweak that? Possibly. But these kinds of changes don't happen a lot, right? We don't do day two changes to infrastructure very often, but they are an important part of the whole deployment, and they do happen. And when they do happen at scale, you need a system to be able to do that.
Yes, exactly. And that system has to operate across those edge clusters. So it can't run on the edge cluster. Two, I'm contending that one of the differences to me in this upper half is actually that those operators that run in the management cluster, they're actually pushing their changes to a repository where they can be inspected and reviewed by people, by tooling, as opposed to at runtime, when you make a change to a configuration, you're pushing it directly to the live state. Zero opportunity for review, edit, tweaking, tooling to validate. So that's why I believe it's so important to push.
If I may jump in at this point and say something, it sounds like we have two type of human operators. There are the designer and network admin, and the people who follow the upper chain, the management plane, for lack of a better word. And then there is the execute this operator, which is the lower one. And we may, sorry, my alarm going off. If we define the persona type, the user type, then it may help clarify who does what where. Would that help?
Yes, absolutely. And we're out of time, but the idea built into this is that there's a different persona that's sort of taking this from the public catalog, customizing it for the organization, putting it in the private catalog, maybe even another one that takes that and puts more design elements to it, and then a third one that like does the actual deployment detail.
Yeah, like the old-fashioned administrator who just you ask them for things and they give it to you, but they don't really modify things.
Right. Okay, I'm sorry, we are out of time, and I do have another meeting, but I'll send, or we'll figure out. We'll send out an email and try and figure out when we should meet next week.
And was this meeting a regular meeting or one-off?
No, this was an ad hoc meeting we scheduled.
Okay, because it wasn't on my schedule. Sorry.
Yeah. Sorry about that. All right. Are
No
you in the Google group? You must not be in the Google group because you would have gotten the email.
I did get the email, but after I sign off and didn't pay attention to it.
Okay. All right. Thanks, everybody.
Thank you.
Bye.
Bye.